According to the National Electrical Code, it is not legal to place a ground rod on either side of a feeder for a house. The grounding electrode system must be installed at or near the service entrance. This grounding electrode system includes a main grounding electrode, such as a ground rod, and any other grounding electrodes connected to the main one. The National Electrical Code mandates that the grounding electrode system be installed as close to the service entrance as is practically possible. The purpose of this requirement is to ensure that the grounding system effectively protects the electrical system from hazards like lightning and other electrical faults. Placing a ground rod on either side of a feeder does not meet the National Electrical Code requirement for the grounding electrode system to be installed at or near the service entrance. Therefore, such an installation is not legally compliant. The grounding electrode system is a critical safety component of an electrical installation. It provides a low impedance path for fault currents to return to the source, which helps to trip over current protection devices like circuit breakers or fuses and clear the fault quickly. A properly installed grounding system helps to minimize the risk of electric shock and fire. The location of the grounding electrode system is important for its effectiveness. When the grounding electrode system is installed at or near the service entrance, it provides the most direct path for fault currents to return to the source. This helps to ensure that the fault is cleared quickly and safely. Installing ground rods away from the service entrance can increase the impedance of the grounding path, which can reduce the effectiveness of the grounding system. This can increase the risk of electric shock and fire. There are several types of grounding electrodes that can be used, including ground rods, ground plates, and metal underground water pipes. The National Electrical Code specifies the requirements for each type of grounding electrode. Ground rods are typically made of copper or copper-clad steel and must be at least 8 feet long. They must be driven into the ground to a depth of at least 8 feet. Ground plates must be made of copper or other approved material and must have a surface area of at least 2 square feet. Metal underground water pipes can be used as grounding electrodes if they are in direct contact with the earth for at least 10 feet. The size of the grounding electrode conductor, which connects the grounding electrode to the service equipment, is determined by the size of the service entrance conductors. The National Electrical Code provides tables that specify the minimum size of the grounding electrode conductor. The grounding electrode conductor must be made of copper or other approved material. It must be protected from physical damage. The grounding electrode system must be properly bonded to the service equipment. This means that all of the metal parts of the service equipment, such as the service panel and the meter enclosure, must be connected to the grounding electrode system. Bonding helps to ensure that all of the metal parts of the service equipment are at the same potential, which reduces the risk of electric shock. The National Electrical Code also requires that the grounding electrode system be tested periodically to ensure that it is effective. The testing should be performed by a qualified electrician. The electrician will use a ground resistance tester to measure the resistance of the grounding electrode system. If the resistance is too high, the electrician will need to take corrective action to improve the grounding system. It is important to note that the National Electrical Code is a minimum standard. Local codes may have additional requirements for grounding electrode systems. It is important to check with the local electrical inspector to determine the specific requirements for your area. In summary, the National Electrical Code prohibits the placement of ground rods on either side of a feeder for a house. The grounding electrode system must be installed at or near the service entrance to ensure effective protection from electrical hazards. The grounding electrode system must be properly installed, bonded, and tested to ensure that it is effective. Always consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes. The NEC Section 250.24 addresses grounding service supplied alternating current systems. It states that the grounding electrode conductor shall be used to connect both the grounded conductor and the equipment grounding conductors to the grounding electrode. This section emphasizes the importance of a single, unified grounding system connected at the service entrance. NEC Section 250.50 covers grounding electrode systems and requires that all grounding electrodes that are present at each building or structure served be bonded together to form the grounding electrode system. This section reinforces the idea of a comprehensive grounding system rather than isolated ground rods. NEC Section 250.52 details the specific requirements for grounding electrodes and includes items like metal underground water pipes, metal in ground support structures, ground rings, and rod and pipe electrodes. This section clarifies the acceptable types and installation requirements for grounding electrodes, all of which are intended to be part of the unified grounding system at the service entrance. Placing ground rods on either side of a feeder would create separate, unbonded grounding systems, which is a violation of the NEC. The intent of the NEC is to create a low impedance path for fault current to return to the source, tripping the overcurrent protective device such as a circuit breaker or fuse. Separate grounding systems can impede this process and increase the risk of electrical shock or fire. The primary reason for grounding electrical systems is safety. Grounding provides a low resistance path for fault currents to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. This helps to prevent electrical shock and fire. Proper grounding also helps to stabilize voltage levels and reduce electrical noise, which can improve the performance of electrical equipment. The grounding electrode system should be installed as close as practical to the service entrance to minimize the impedance of the grounding path. This helps to ensure that fault currents can quickly and easily return to the source. The NEC specifies the minimum size of the grounding electrode conductor, which is based on the size of the service entrance conductors. The grounding electrode conductor must be large enough to safely carry the maximum fault current that could occur. The grounding electrode conductor must be securely connected to the grounding electrode and the service equipment. The connections must be made using approved methods and materials. The grounding electrode system should be inspected and tested regularly to ensure that it is functioning properly. The resistance of the grounding electrode system should be measured using a ground resistance tester. If the resistance is too high, the grounding electrode system may need to be improved. Improper grounding can create a dangerous situation. If a fault occurs in an improperly grounded electrical system, the fault current may not flow back to the source quickly enough to trip the overcurrent protection device. This can cause the metal parts of electrical equipment to become energized, creating a shock hazard. Improper grounding can also increase the risk of fire. If a fault occurs in an improperly grounded electrical system, the fault current may flow through unintended paths, such as through the building structure or through flammable materials. This can cause a fire. It is important to hire a qualified electrician to install and maintain the grounding system. A qualified electrician will have the knowledge and experience to ensure that the grounding system is installed properly and that it is functioning safely. Always consult with a qualified electrician before making any changes to the electrical system. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical shock and fire. In addition to the grounding electrode system, there are other important grounding and bonding requirements in the NEC. These requirements are designed to ensure that all of the metal parts of the electrical system are properly grounded and bonded together. Equipment grounding conductors are used to connect the metal parts of electrical equipment to the grounding electrode system. Equipment grounding conductors provide a low impedance path for fault currents to flow back to the source. Bonding jumpers are used to connect different metal parts of the electrical system together. Bonding jumpers help to ensure that all of the metal parts of the electrical system are at the same potential, which reduces the risk of electrical shock. The NEC specifies the minimum size of the equipment grounding conductors and bonding jumpers. These conductors must be large enough to safely carry the maximum fault current that could occur. The equipment grounding conductors and bonding jumpers must be securely connected to the metal parts of the electrical system. The connections must be made using approved methods and materials. The equipment grounding conductors and bonding jumpers should be inspected and tested regularly to ensure that they are functioning properly. In summary, the National Electrical Code provides comprehensive requirements for grounding and bonding electrical systems. These requirements are designed to protect people and property from electrical shock and fire. It is important to understand and comply with these requirements when installing and maintaining electrical systems. Always consult with a qualified electrician to ensure that the electrical system is safe and compliant with all applicable codes. The NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC is available for purchase from the National Fire Protection Association. Many states and local jurisdictions adopt the NEC as their electrical code. It is important to check with the local electrical inspector to determine the specific requirements for your area. The goal of the NEC is to provide a safe and practical standard for the installation of electrical wiring and equipment. By following the NEC, you can help to ensure that the electrical system is safe and reliable. Grounding and bonding are essential for electrical safety. By understanding and complying with the NEC requirements, you can help to protect people and property from electrical shock and fire. Remember to always consult with a qualified electrician for any electrical work.